lovely technical Tuesday. I'm joined currently by Chief Science Officer Matt Ikle and Chief AGI Officer Dr. Alexey Potapov. And then Ben should be joining us shortly, Chief Executive Officer, CEO of SingularityNET. Vita, unfortunately, our project manager for Hyperon couldn't join today. There was an issue where she's unable to join us, unfortunately. But we'll look to catch up with her in the next few weeks as this alpha launch unfolds. So the big news today, we're launching the alpha of OpenCog Hyperon. Couldn't be more excited. So many things are coming together and development has proceeded so well, actually on track, which is exciting and unusual for AGI, which things tend to take longer than you think. And this has just been an amazing process watching it unfold from AGI 22, I believe, when it was first announced. Now 2024, here we are with an early alpha launch. So we'll start off by diving into that. First, I'd like to ask Alexey, can you talk a little bit about what this alpha launch looks like for you and what the community should expect and developer community and general community should expect from this alpha launch?
Hi everyone. So, as for what this alpha launch for us, it's about achieving some state of our development when we can say that there is something at least a little bit stable. So it's not just for very internal group of people who can keep tracking all the changes, but external early adopters can start playing with it. Because while it is still alpha and a lot of things will be changed, but we can say that some core elements of the language are indeed stable to a certain extent and can be shown off for the wider audience. And we can start working on more agile things on top of this core system. It's not like we have not been working on more agile things because, as we reported to the community, there was progress on PLN and inference control, on porting other cognitive architectures like NARS or Iris to Meta, and it was quite interesting and successful in terms of actually bringing different things together and in order to see how different cognitive architectures can actually be implemented on the same cognitive substrate. But we personally, who are working on this core system, we're quite limited in our time to work on AGI, and we finally can return to it. So for us, it's a stage after which we first of all will show method to a wider audience, and by ourselves will work on more higher level and more advanced stuff on top of Meta, and we'll proceed finally to performance issues because we didn't want premature optimization to happen, and but unfortunately at this moment of time we really see the necessity to solve performance issues. So yeah, I guess that's my answer to your question.
Thank you. Yeah, and which makes sense as a development cycle. We took a step back from the strictly AGI-ish developments, which were limited by the lack of scalability in OpenCog Classic, we took a step back or a step sideways to develop the outlying theory of what we needed in a language, in a scalable system, in a distributed atom space that would be decentralization ready. Now that we've got that framework, it was exciting to see, I think, earlier mid last year when your team drew in the rest of the AGI team to start experimenting and learning Meta and giving that rich feedback, how that was a step change for Meta. And now we're opening it out to a wider dev community to get that same sort of feedback and interactivity to help it develop in directions that are optimal for a wide utilization in AI, in AGI. And now that we've kind of gotten to this minimum spot, now we can start to build on AGI processes again, solidify that, make it more scalable and efficient, and build on that. Matt, perhaps you can touch just a little bit on what you find exciting about this alpha launch, what this alpha launch means for you and for the next step in OpenCog Hyperon.
Sure. So it really sets the foundation upon which a lot of our AGI research and development and really implementation, because we believe we have a whole bunch of ideas that we've experimented with previously on OpenCog Classic, combined with some new tools and ideas that have developed. Obviously, large language models are recent, and those are being incorporated into our prior work, but really sets the foundation. Alexey and his entire team and everybody else working on this alpha release have really done an incredible job. And I'm often blown away by how innovative Meta really is as a language, truly designed thought through from the ground up. What is it that we need in a language to further AGI development? And so it obviously there's some things that need to be ironed out. Alexey touched on scalability issues, but this incredible foundation, and it really sets the stage to invite the whole developer community in to come in, play with Meta, help us build more tools, crowdsource these tool developments so that AGI can become a reality sooner than ever.
Which is what we're looking forward to, right? Getting to AGI, getting to the singularity, so that we can manifest all the promise of truly intelligent machines that can be companions and work alongside humans and be a new source of intelligence on the planet. Massively exciting. Yeah. Thank you very much. Ben, thank you for joining. So good to see you. I hear that you'll be in and out a little bit on this call. So I thank you very much for being here. We're just touching a little
we've
bit
got
on
so much going on in SingularityNET these days, and we've got like 14 people from Rejuve Network and Rejuve Biotech here visiting our local office, and so that's super exciting to be pushing forward on the AI for super longevity, but has randomized my schedule a bit. But there's been a bunch of Hyperon stuff popping up there for sure, because I'm in the, and that's one angle into the Hyperon Alpha and why it's exciting, because what we're looking at doing there with Rejuve Network and Rejuve Biotech, among other things, is building a massive cross-connected data set of all biomedical and biological data sets that have been opened up anywhere on the planet, right? And we'll start out with data sets about human longevity in particular. And then Drosophila longevity, but then ultimately longevity is about every system in the body and their cross connections. We can now use LLMs to help read the metadata in data sets to automatically cross-link them with information extracted from text. And with biological ontologies, we can make this massive cross-connected data set of everything known about human body, or at least everything put out there in the open domain, which is quite a lot now. It's just scattered all over the place. Then you need to ask questions of all this knowledge, right? And it's not just number crunching. It's integrating together quantitative data, other sorts of data like genomic data, then relational data, information that's in research papers and so forth. And so Hyperon is a fantastic tool for doing this. Now we need it to be workable at large scale for this, right? Because we need a big atom space, much bigger than the current bio atom space. And I mean, we need queries of some complexity to be resolved rapidly. We also need usability, because we need bioinformatics developers to be able to write scripts that weave together Hyperon-based functions with other sorts of bioinformatics data crunching, right? So I mean, there's a lot of requirements on the Hyperon infrastructure, some of which are met by the current alpha release, some of which are not yet met by the current alpha release. But we have a clear roadmap to meeting all these requirements before too much time has passed. And yeah, that's one among a host of applications that we could point to. So in our same little office here in Seattle area, where I'm meeting with the Rejuve team now, we're working on a project called Mind Children, which is like a 3-foot tall robot. So it's like the little brother and sister to the Hanson robots of Sophia, Desdemona, and Grace. We're building a new software architecture from the ground up for these little robots, and they're mobile. They can roll around easily and pick things up and manipulate small objects and so forth. And we will mirror these with virtual agents in the Sophiaverse virtual world. So we'll have simulated robots in Sophiaverse interacting with Sophia avatars and other characters. And again, this sort of learning system, a robot or an avatar going around in the world learning what to do, I mean, this demands an open-ended learning and reasoning framework like Hyperon is. I mean, we're even we're looking at very simple things now, like getting little robots to play children's games like hide and seek or freeze tag or something, right? And play charades and imitate different kinds of movements, but not by hard coding a system to do these games, which would be trivial but uninteresting, rather by having a system to learn to carry out games like this as part of its engagement with the world and with people in the world, fulfilling its own intrinsic motivations, its desire for joy, curiosity, social interaction, and so forth. And by going through children's games in a self-motivated, open-ended, learning-based way, these systems then build a grounded understanding of self, other, and world, which can then be brought into every other domain, including biology, data analysis, natural language question answering, and so forth. Right? You look at talking to ChatGPT, Mistral, systems like this. They don't really know who they are. They're just putting on various fake personas. They don't know who and what they are. They don't know who you are, what sort of entity you are. They don't have a fundamental self-other world understanding. They don't have a fundamental grounded world model. And we're looking at building fundamental grounded world models for proto-AGI systems, in part by using our proto-AGI systems for controlling robotic and virtual agents. And to do all this, I mean, you need a lot. You need good learning and reasoning algorithms. You need a cognitive architecture that handles interaction between perception, action, memory, reasoning, learning, and so forth. But you also need a solid infrastructure in which all these other ingredients can be integrated in a scalable and operational and usable way. And this is what Hyperon supplies. So, I mean, we've been working in this direction with OpenCog Classic system for a number of years, and we realized at a certain point, if we really wanted to scale things up to artificial general intelligence and an AGI that can then build super intelligence, I mean, we needed to have a more scalable, usable, solid foundation than OpenCog Classic was at that time. I mean, OpenCog Classic still exists. It's improving all the time, but I think there's a number of substantial advantages to the way Hyperon is architected, and I'm excited that we've reached a certain threshold in Hyperon development now. That doesn't mean the Hyperon Alpha is able to do all these things we're looking at in medicine, robotics, gaming, and every other vertical market right now, but it means it means we have a system that we are comfortable at this point inviting developers from around the world to plunge in and help us move things along to the next level. I mean, alpha still can have breaking changes going forward. So we're not yet at something that's fully nailed down and solid, and we're not going to change anything. We don't yet have something that we're saying you want to run your air traffic control system on this, right? We'll get there, but we're at the point now where things are nailed down enough. Like we're not boiling the oceans anymore. I mean, we have the basics under control. We have our own team who is using the Hyperon Alpha right now to do reasoning on biology data sets and to carry out a number of other sort of early stage AI learning and reasoning experiments to control simple agents in simple virtual worlds and so forth. So we have a system now that's solid enough. We believe it makes sense to invite in a broader developer community to help us take things to the next level. And what's needed to take things to the next level, Alexey and Matt have said a little about it and can say more about it, as can I. I mean, we need the meta interpreter to become faster, and we have a few different projects in parallel which are showing great promise at moving in that direction. So I believe it's months, not years or something. It's a few months until we have a significantly more rapid meta interpreter, and we need richer integration between distributed atom space and different lobes of distributed atom space with the localized version of meta. But again, that's coming along very rapidly under the leadership of Andre Senna, who was the lead author of the first version of the OpenCog Classic atom space way back in the dark ages. And we need implementation of more and more cognitive algorithms and representations for different aspects of AI within the Hyperon framework, which is the aspect of it that I'm most suited to work on by my own background. And there's a lot of different threads we're pursuing there. Some of them aligned with the applications I've outlined, some in different directions. And we're looking forward to pulling more and more of the community in here, both on a volunteer open source contribution basis, and then through the deep funding program. So now that we have a version of Hyperon that is, we believe, at the appropriate level of solidity to start pulling in a broader developer community, we can now work with Jan Horlings and the others in the SingularityNET deep funding program to work on issuing the right calls for proposals to incent with AGIX tokens, incent the developer community to build various things on top of Hyperon. I mean, we're not looking just to contract out work to people who just want to do this on the work for hire basis, but we want people who are passionate and enthused about building the world's first real thinking machine, but who will be enabled to spend a little more of their time on this if there's a tokenomic incentive to help with compensation. So I'm seeing some interesting questions here. Let me address just a couple. So someone says they have an awkward question. Is Nick? OpenCog Classic has accumulated a lot of potential over 40 years of development. Well, it's not been that long. Why do you rewrite it from scratch? Don't you think it may take another 10 years? Well, no, it won't. I mean, OpenCog Classic was not developed for 40 years either. I mean, the underlying concepts have been under development for a long time. That OpenCog was launched in 2007 or 8, I guess, and it built on the Novamenti cognition engine that was launched in 2001. So it is a long time, but it's not 40 years. And yeah, the decision to rebuild something from scratch is always hard and was complicated. And Alexey and I have also talked about this at great length in previous videos. So I'm more interested to focus on the future here than the past. But just to say just a little bit about that. And I don't want to be negative toward OpenCog Classic at all, which is still a vibrant and very cool software system. But I mean, if you look at the way the OpenCog Classic pattern matcher works in detail, which is a very technical thing to look at, I mean, the pattern matcher there sort of tries to bake a whole complex programming language into the pattern matcher. And this I think is not a sufficiently flexible or scalable way to do things. And we rearrange things via Alexey's insight primarily and Vitaly Bogdanov's in OpenCog Hyperon, wherein pattern matching is a simpler static functionality. And then we have a custom language meta that wraps up the pattern matcher rather than having a complex pattern matcher that sort of wraps up a language via callbacks inside it. So I mean, this is a technical point, but it's a very meaningful point, right? Then, if you look at Alexey and Vitaly's work, and I guess it was 2019 with cognitive module networks, where we were trying to connect deep neural networks running outside of OpenCog with things happening inside OpenCog. The way that you associate OpenCog nodes with deep neural modules outside was simply awkward in OpenCog Classic. It was going to be very hard that way to do things like co-train a deep neural net model and the logical model inside OpenCog, where the learning occurred synchronized in both sides at a high rate of speed. It just wasn't clear how to do that. So there was that. I just raised 2 points. There was just a significant number of difficult technical points that we encountered in trying to make OpenCog Classic massively scalable on the level of, say, a transformer neural net or something, right? And you could solve any of those problems within OpenCog Classic framework. It just seemed difficult and laborious. And it seemed like to solve all those problems in that framework would be more work than to rebuild something from scratch, because the bar is pretty high these days, right? Like, I mean, transformer neural nets do a lot of things. LLMs do a lot of things. Convolutional neural nets do a lot of things. We need an OpenCog Hyperon framework to be more scalable than all these things, not to be playing catch up. And it seemed like to get to that level of scale while maintaining the usability and flexibility you need for an AGI system, to get to that level of scale was going to be faster by rebuilding from the ground up than by awkwardly patching 25 things onto a legacy framework, right? And I mean, if you look in regular software development, it's like the shift that Apple made going from OS 9 to OS X, right? Like at some point, to make a operating system that was future oriented, they started all over, and OS X was just a new system built from the ground up, and that I mean was certainly the right thing to do there. I think it's been the right thing here, and there's no way. I mean, development may take another 10 years. Development may never end, but 10 years from now, it's going to be the AGI doing the development. I mean, it's really clear just from the standpoint of being on the ground working with the system. Like we're building reasoning and learning engines in Hyperon right now, right? So I think yes, there's more work to do, but I think within 1 year from now, we'll have a massively scalable Hyperon system that's doing a whole bunch of super cool things across a whole bunch of application areas. And 2 or 3 years from now, we may have very serious headway toward AGI, like a human level AGI. I mean, I think we're on a trajectory toward realizing Ray Kurzweil's vision of human level AGI by 2029. We may even shave a couple of years off his proposed deadline. And but I think to get there, we needed a massively scalable infrastructure that would allow us to implement the cognitive architectures and representation and learning and reasoning ideas that we were prototyping for so long in OpenCog Classic. But I mean, there's always a lot of tough calls to make in trying to build a complex system like this. You can never know for sure what you did was optimal, but so far, I think things have come out great. Like when we started with Hyperon, we were wondering like, well, will it really take 5 years to get a new programming language up and running at all? Like, is it are we going to need to put into distributed app space all the work that was put into building version 1 of Neo4j, which took them like 5 or 7 years? So far, development has actually gone pretty much on schedule, which is quite rare for such a large and complex project. So I think so far for myself, the evidence is strong. This was a good direction. Like things haven't dragged on in insane, weird ways. We haven't hit huge hidden rocks where we're like, oh shit, this will take us 2 years to figure out what the hell we're doing. I mean, things have gone relatively well given the complexity and novelty of the project. And so I mean, as an example, I mean, we've got PLN logical reasoning examples and NARS reasoning examples running already. We need more scalability to do it at the level we want, but we're doing reasoning in Hyperon now, and we're now just starting to port Moses, which is the probabilistic evolutionary programming algorithm, into Hyperon, right? So my recent trip to the SingularityNET ICOG office in Ethiopia, we were gearing up a team of brilliant young developers there for working with Neil Geisweiler on porting Moses into Hyperon, but it's not the same as the OpenCog Classic version of Moses, right? It's going to be much more concise, much more elegant, and much more efficient due to the meta language just being a far better infrastructure for automated program learning than anything that has existed on the whole planet before, actually, let alone just in OpenCog Classic. Now that, of course, being at the stage where a version of probabilistic evolutionary program learning in Hyperon is great, it's different than having that toolkit already scaled up, super efficient, and easy for everyone to use as a library in their applications, right? So we're not there yet, but we're at the point where we can invite developers to help us build these libraries of AI functions in Hyperon that then in the following phase will be used to juice up everyone's applications toward AGI.
Excellent. Thank you very much for that overview, Ben. It's so powerful. It's been so exciting to see in the development of Meta how the developer community at AGI conferences and around the world that we know has gotten excited about the various pieces that we're doing here. The NARS team got excited about the capabilities of Meta within their own work, and we've drawn in a number of other projects as our own developers have gotten into Meta, gotten into DAS, they've only become more excited about the possibilities that this unlocks, even with the challenges that are currently there as a young and a new language. Now, I have a quote from you, Alexey, that I'd love for you to dive into about Meta itself, and maybe we could just take a moment to talk about Meta as the language. But Meta is unique in its ability to write introspective and self-modifying programs, which can be crucial for recursive self-improvement of AGI. It's like a modeling clay robot that can sculpt itself. Can you dive a little bit into what makes that unique and what makes that valuable for future AGI?
Well, yes, when someone asks me what personally I find interesting about Meta, it's actually quite difficult to answer because on the one hand, Meta was deeply inspired by atomies from OpenCog Classic, and actually our initial intention was just to make a clean re-implementation of OpenCog Classic with a bunch of improvements, because as Ben mentioned, it was just a necessity to make some minor improvements and so on. And we had some ideas of how to make things a little bit different. And I definitely agree with Ben's analogy that in software engineering, many systems got rebuilt at some point of time nearly from scratch, but it is much simpler to rebuild a system than to invent the system. So we didn't throw out the years of development of OpenCog Classic and experiments with them. Quite opposite. We built it on top of these results. Initially, it was like a fresh rebuild of what we had, but finally it turned out to have some internal synergetic effect and value. And indeed, when I think about Meta and compare it to other languages, what I like a lot about Meta is a sort of freedom. I can write programs which are kind of arbitrary. Sometimes it's a bad thing because it's difficult to track bugs and so on, but this can be mitigated by additional means. But I can just write some code which looks like a function, but I can query the body of this function, analyze it, transform it, put it back, and so on. And it's indeed a very interesting feeling when you are working with this, that it kind of gives you some additional capabilities. And in the field of AGI, there is, of course, an idea of incremental recursive self-improving AGI. So AGI should be able to start improving itself at a certain point of time. And there are different theoretical models like Gödel machine by Jürgen Schmidt-Huber, and they even tried to start implementing it like 13 years ago, and they started with inventing a self-introspective version of Lisp to do this, but Meta allows doing much more interesting stuff. And for example, why couldn't we try implementing the Gödel machine in Meta. So it allows us to implement something which wasn't actually planned. Like we didn't plan that NARS will be ported to Meta, and when the developers of NARS said that, well, it took like 500 lines of code instead of 10,000 lines of code to do this. So this is a real effect of using Meta. So its design appears to be very productive in implementing different theories of AGI, of cognitive architectures, and so on. I believe it can be very important for self-improving AGI as well. Maybe I got a little bit far from the question, or
No, I think that the recursive self-modifying ability of OpenCog systems is certainly one of the things that attracted me. It feels like a true component of intelligence, at least our model. And as we try to build machine intelligence, we can only program it in the way that our minds work, right? It's in language that we can understand using if and or for a combination of ones and zeros that a machine can understand. So allowing an AI system to understand itself and self-modify in a way that it can think more natively as a machine, I find incredibly exciting and intuitive as a way to get to machines that are more intelligent and can learn more tasks. I'd be interested to hear a little bit more, if you can, dive into what unique problems Meta. I'm so excited as well about how multifunctional it's become, right? As you said, we didn't expect to port NARS into Meta. We didn't expect a lot of the developments, a lot of the parallels that have happened. We didn't build it to be a smart contract language for hypercycle. It just happened that it's got this fluidity. Can you speak a little to some of the unique possibilities that Meta enables and why it's able to do things that others can't, or that it wasn't originally envisioned for?
Well, it's a difficult question because everything can be written in an assembly language. So it's difficult to say that it enables something which cannot be done by other means, like PyTorch or TensorFlow didn't enable deep neural networks. They just greatly simplify the automation of calculation of gradients, and this was so convenient that it provided opportunities to write and test a lot of models instead of losing time on inferring gradients manually or something like this. So I believe it can be a valid analogy to say that Meta may play a role for symbolic computations, which is similar to PyTorch or TensorFlow role for DNNs, because it indeed provides a very flexible way to just construct symbolic systems with some rules or knowledge or inference engines or whatever. So it's just about transformation of arbitrary symbolic constructions, and it indeed can be used not just directly for cognitive architectures, but also for different stuff. For example, we mentioned MetaMoto, which is a library for manipulating LLMs from Meta, and it also provides a lot of convenience. It is not embodied right now, because if we compare it to more mature libraries like LangChain, it lacks some infrastructure, some bindings, some interoperability with a lot of external stuff, but the engine itself for composing prompts, for chaining LLM calls, for combining them with calls to knowledge graphs, with reasoning and so on, it's very, very native. So it's so native in the meta then that when you're already familiar with meta, you will hopefully will not want to write such engines for processing something manually. The same can be true for maybe not very state of the art now, but still relevant rule-based dialogue systems, because when you want some goal-oriented dialogues with some very concrete outcomes, you will start thinking about what it should do in this or this case, and you will end up with designing an ad hoc language for such systems. But when you have meta, you don't need to do this, because you already have a general framework to doing this sort of stuff. And the same can be true for say SingularityNET platform SDK for combining AI services on our platform. So instead of just coming up with some ad hoc language for describing the structure and APIs of the services, on top of Potapov, which is good for low-level communication, but is not enough for describing semantics of services, in particular AI services. Once again, you will end up with some ad hoc solution, but you may not need it if you use meta. I'm not sure about hypercycle smart contract language. Actually, I'm not. These ideas were discussed a lot, but I'm not aware if they are indeed working on this. Meta, well, if we take some smart contract languages, we move from Ethereum to Cardano, and Cardano uses Haskell, and there were ideas of using more advanced languages in terms of automated proofs, automated verification of code, including smart contracts like Idris, which is a dependently typed language. Meta is of course, is suitable here. It is not as strict as Idris, but it provides more capabilities. I am not an expert in smart contracts, and it's difficult for me to be absolutely sure, but I believe Meta is quite suitable for smart contracts, although we absolutely didn't consider it as an application. So yeah, there are various possible applications of Meta which we didn't consider initially when we started designing this language.
Yeah, it's amazing, and probably the mark of a good language when the design of it is for something wider than we originally intended. That it's got that kind of robustness and flexibility built in. So we've heard a lot about the alpha launch. We're going to open up for the community an invitation to join some of our internal meta study groups for people that are interested in learning the language and what it entails and helping to contribute and give feedback. So that will be announced shortly. We've got a lot of tutorials and demos that will be rolling out over the next months to dive in deeper and deeper. This is definitely a rolling launch. But can you speak a little bit today? What's ready for the alpha launch? How can people get involved, and where can they go to learn more?
Well, I believe Peter already submitted a link to MetaLangDev. So this site is still well, not under construction, but its content is being updated. I'm not sure I can just try sharing the screen to show the site, or anyone can go to the web page itself and see. There are already some basic tutorials, not advanced tutorials at the moment, but we will be adding them. There is a link to the GitHub repo, and there is a playground, which is actually an empty box of for examples which are in the tutorial itself. So you can run some examples and get some result. In some cases, you can even edit them. I'm not sure where is it, but if you just go to the playground, you can put your code and see what's happening. One quick comment is that right now this playground code runs on a server. It's not JavaScript or WebAssembly. That's why it has limited bandwidth. So there are just a few instances which can run simultaneously. We decided to do this in this way because we don't expect too many people trying it simultaneously, but just please note that it may not work always for you if such collisions happen. But in what we can do with this server-based version, we even can run some Python code, which would be difficult to do using JavaScript or WebAssembly. So it's 100% authentic interpreter. So it should work in the same way as you install Hyperon from the source, or using PIP as a Python package. So if you are interested in Meta, you can read the first three tutorials, which are ready, and others will be being added in the upcoming days and weeks. There is also a meta study group, which anyone is welcome to join. It's our internal calls, but if there are more people who would like to ask questions and learn some basics, we may organize another type of meta study group calls for the newcomers. Is it enough?
Yes, wonderful. Thank you. Yeah, so definitely check out the website. You can read all about meta, just the theory. You can get on the playground. You can look at some of the tutorials. We'll have a lot of demo videos rolling out. Actually, the NARS team, I believe, will be in Japan, showing a real robot working with the Meta plus NARS system. And so we're hoping to get a recording of their presentation and demonstrate that, or create our own demo with them around that. So we'll be seeing a lot of really interesting things rolling out shortly. Now, we appear to have lost Matt's connection. Ben had to drop as well. I was hoping to oh, there's Ben. Just to just to talk, either Ben or Alexey. Ben, if you have a moment, or Alexey, what's next? What should we look forward to over the coming months as we get towards beta and beyond?
Oh well, that is obviously a very, very big question, right? I mean, I think between alpha and beta, quite a number of things will happen, but I think the two main things on my mind are scalability and usability, right? And so I mean, I think those are all both big things that have a number of different sub aspects as well, right? So I mean, for scalability, there's a few initiatives underway aimed at making radically sped up versions of the meta interpreter, sped up by orders of magnitude, but that defining what that means and in what respects we need it to be faster also becomes a bit subtle, because you're looking at building systems that can self-optimize and self-improve, but some functions you do want to be significantly speedier than is the case in the current alpha. Then scalability in terms of breadth, we want a system that can run distributed across many machines in a tightly coordinated way. That again has many different aspects, some of which are in the realm of traditional computing, and some of which verge into SingularityNET, hypercycle, NuNet, and decentralized computing. And we've designed Hyperon from scratch so it can operate effectively on centralized server farm setting, or it can operate effectively on a more heterogeneous decentralized network, and that goes for distributed atom space as well as a meta interpreter and the in RAM atom space and so forth. In terms of usability, I mean, there's many different aspects. There's tooling that one can do to make meta programming easier and better integrated with different development tools. There's testing and visualization frameworks. And I think one of the most important things, though, will just be the development of appropriate libraries for doing a lot of the both routine sort of programming language tasks and AI tasks that are commonly going to come up. And this really brings us to the question of what kind of adoption we need to get for a somewhat complex and novel language such as Meta. So I think Meta is very abstract sort of language, right? Like in some ways, I mean, from a sort of programming language geek view, I mean, languages like Haskell are more elegant, in some ways more secure and sound than the commonly used imperative languages. But function languages like Haskell are often viewed as harder for the average casual software developer to get into. So then languages like Idris or Agda add more mathematical bells and whistles with dependent types and so on. They're a little harder for average developers to deal with. And now Meta in some ways goes goes beyond these things, right? So on the one hand, you could say we're building a language that's very complex and abstract, when the average developer barely wants to use Python these days and would rather use LLMs to script their Python for them, right? But then the way we're looking at it is we need a relatively modest-sized group of very capable AI developers. I mean, bigger than our current team within the SingularityNET and allied companies, but not as big as the global community of Python developers or something, right? We need a relatively modest-sized group of people who can wrap their brains around Meta and Hyperon and the Primus cognitive architecture, and then write a bunch of really strong AGI-oriented library functions, doing things like automated reasoning, automated program learning, management of perception, episodic memory, and so forth. And as we have this system of libraries packaged up there, then this gets us a number of things. I mean, it means that we can do automated program learning to concisely learn control programs that utilize these libraries to do things, which is in some ways the main point. It also means that developers who don't want to dig into the guts of Meta can write quite simple scripts in Python or their language of choice, or can tell an LLM to write a script for them, combining these libraries coded in Meta. And a very rough, imprecise, but still useful analogy is there's not that many CUDA programmers in the world, right? There's not that many programmers who are programming libraries in CUDA to do matrix manipulation and other sorts of learning algorithm plumbing on NVIDIA GPUs. There's a non-trivial community of CUDA developers. They have conferences every year, right? But it's not as many as there are developers using Python to access GPU libraries written in CUDA, right? So you could, as a first approximation for an early stage of development, you could view Meta as a language sort of like CUDA is. I mean, it's not the same. CUDA is for specific hardware architecture, but it's similar in that it's somewhat in depth and requires some specialized expertise to efficiently do development. But what you're writing is packaged up libraries that a bunch of other developers can then easily use, right? Now there may be a couple of years later a future where Meta has been made super easy to use, as easy as Python is now. I think it's totally possible. We can have 8-year-old kids coding using Meta. I mean, Alexey's daughter may be doing it already. I don't know. I mean, I don't think it's intrinsically that hard. On the other hand, we don't need that to get where we want to go, right? What we need is to have a modest community of developers build very efficient, easy to use AI libraries, which can then be used by a larger community of developers to build application programs, and can then be used by AI itself to learn scripts that wrap up these library functions, right? So I mean, we don't actually need Meta to become a super widely adopted, easy to use programming language to get to a human level thinking machine. Although, I mean, any progress we make in that direction, or the community makes in that direction, will certainly be helpful in various ways. So there's one more question I want to address, actually two. One is, why don't I get Starlink? I spent like 2 days screwing around with the Starlink dish on top of my house. I couldn't get a connection. So I live in a rural area with a satellite internet. It kind of sucks. But our office where all the robots are being developed has fast internet. But I didn't haul my ass in there yet this morning. But the more interesting question people are asking, like, is scalability actually important? Moore's law will speed everything up. Well, I mean, that's, to be not too crude about it, I think that's very naive. I mean, if you look at what OpenAI and others have done with transformer neural nets, I mean, it's very clear that scalability is key. Like the big lesson that I draw from the big successes recently with transformer neural nets, the high level lesson I draw is you can take some old AI ideas tweak the algorithms a bit, train them on shitloads of data and compute, and you'll get tremendously more amazing results, right? And I mean, that's a general lesson that I think doesn't only hold for LSTM, transformer neural net, and algorithms in that domain. So I think we can do the same for logic-based AI. I think we can do the same for evolutionary AI. We can do the same for hypervectors. There's an array of different classical AI paradigms, which, when deployed on the right amount of data and a suitable scale, are going to start to do amazing and incredible things. And you want to be able to network these together in a frictionless large-scale framework. So yes, Moore's law is a critical part of it. It's very important that computers are doing faster and faster things, cheaper and cheaper. However, scaling up your algorithms and representations is also a key part of it. And this is exactly what we've seen with transformer neural nets. You needed more processors. You also needed to jigger the algorithms differently and write the code differently, and then you can get amazing results. So I think we need both. I mean, it's not either or. We need faster and faster hardware and more RAM and more efficient networking, and we additionally need scalable infrastructure that lets us take advantage of this. And this is how we get to human level AGI by 2029 or 2026 or something, right? I mean, it's, yes, in principle, I'm almost sure there is some software approach that would get us to human level AGI running on, relatively modest hardware, running on a few laptops mainly, right? But it's harder to find those routes. What's a clearer path now? What it seems very clear that we know how to do is scale up Hyperon so we can do large scale versions of all the promising classical AI approaches in modernized versions, have them operate together and run those on massive amounts of hardware, combining centralized server farms and decentralized AI networks. And this is like a practical thing that we're in the middle of doing right now. So I mean, it's true there's an alternate path to try to find the most intelligent possible AGI approach, which could then run on the minimum amount of hardware, and then you just worry about math of AGI and not about hardware infrastructure. That appeals to the mathematical part of my mind. I don't think that's the fastest way to get to a beneficial human level AGI, given the totality of where we are right now. So yeah, that's in any case, like I said, in the context of OpenCog Classic versus Hyperon, there's a series of difficult judgment calls to be made in trying to create something that no one on this planet has ever created before. There's not only one path that can work. There's going to be a lot of viable paths. We've got to choose what we think is the path most likely to succeed within the time and resources available. I mean, we're doing that by our best judgment, and there is room on the planet for a whole bunch of AGI approaches. So it's not just snarky to say, well, if you think there's a better way that doesn't need so much scalability, go implement it. I'm serious. Please do. And I will love if it works and comes up with a beneficial AGI. I will also love if it doesn't fully work, but we learn something new from it that we can integrate with our own development. I mean that's great. There shouldn't be one monolithic approach. This should be a decentralized network of approaches to AGI, which can then run on computational decentralized networks. And I've got to get to the Rejuve teams now, but thanks everyone for all the passion and curiosity and questions. And we look forward to inviting more people to help us with pursuing this path toward a scalable and generally intelligent Hyperon system. And there's so many more good questions to answer and different aspects to explore. But we'll be doing a bunch more of these sessions in coming weeks.
It's wonderful. Thank you very much, Ben, for that very complete overview and vision on the coming future of OpenCog Hyperon, of Meta. It's so important that we've as we said, we're supporting the decentralized possibility of building beneficial AGI. Hopefully with Meta, we built something that OpenCog Hyperon needs, that our team needs, that didn't exist. And hopefully this is beneficial and helpful to anybody else that wants to dive into that complexity and build AGI with their own unique approach, their own software, hardware, architectural, cognitive theories. And hopefully Meta is a rich, and the DAS and all the pieces that we start to bring together can become rich resources for the global brain to act on.
Yeah, I think I didn't fully answer what's on the roadmap ahead, but I think I tried to answer on a technical level. But on an application level, how I want to say a couple words about that. I mean, we're working on our own sort of in-house or SingularityNET spin-off applications, which both because I think these are important applications, and because I think we need some reference applications just used to flesh everything out and be clear how things will work. But I mean, the goal is to have Hyperon used in the infrastructure of nearly every AI application on planet Earth, and going into space as fast as we can get there. And I mean, in a similar way to how a toolkit like Torch or TensorFlow can be used to train models that can be used in nearly any application on Earth. I think Hyperon can have a similar or greater level of breadth and usage. And of course, the AI economy is rapidly becoming the whole world economy, right? So I mean, we're looking at Hyperon as it grows being quite universal in applicability, and it has the feature of increasing returns, right? Like the more people use Hyperon, the more knowledge gets into atom spaces, and the more incentives there are to make these atom spaces publicly usable in various ways, even if not fully open. In some cases, they will be fully open. Then the easier it is for others to build new applications that give more and more value, right? So we built some Rejuve applications on Hyperon. Then some of the atom spaces that are built have valuable medical knowledge, right? I mean, then for someone else to build medical applications on Hyperon becomes even easier. People build these medical applications which interface with EEG machines and other hospital machinery. Well, then people wanting to use Hyperon for other sorts of complex machinery have an easier time because of the tooling built to connect it to the hospital machinery, right? So there's a clear trajectory you can see where you get more and more adoption. It leads to more tooling being built, more atom spaces being made available. Then adoption across different vertical markets becomes easier and easier for more and more people. We have a few stages to get through, right? So I mean, the focus now is on like more scalability, more usability, building AI libraries, because we're at the alpha stage, right? And so we need people who can dig into the hardcore, help us get from alpha to beta stage, which includes prototype applications as well as work deeper in the plumbing. Once we get to the beta stage, I mean, then we're ready to start the increasing returns loop of having the software, pervade every vertical market and every hardware device and every software application on the planet. And just as we've seen LLMs roll out across different vertical markets with astonishing speed, we're going to see Hyperon roll out across vertical markets with a vastly more astonishing speed than that. I mean, for a couple of reasons. One is LLMs are cool, but they make up so much random shit that you can't use them in most business applications. So, I mean, if you have a system that's not only smart, but has some cognizance or control over what it's saying and why, the speed with which it can roll out through every application will be much, much, much higher. The other thing is we're not constrained by being able to run only on a few huge server farms, because we're building this for decentralized infrastructure from the get-go. So I think once we get through this next stage of development, through superior level of intelligence and through a more flexible infrastructure, I think we're poised for a much more rapid growth than what we've seen with LLMs, which is already pretty rapid by historical standards, right? So there's a lot coming ahead if you look a little further ahead, but it's also important to look at the concrete development steps that we have to carry out now to get from alpha to beta. Or now I'm late to meet with the Rejuve team, but I couldn't help unburdening myself of that additional thought. So thanks, Haley.
Thanks very much, Ben. Yeah, thank you very much, Ben. Thank you very much, Alexey. It's been an absolute joy to dive into this.
Sorry, I can't help, but I would like to answer one more question from Paul, because this question was directed to me, and it's about technical reasons. So I just like technical questions. So the question was, what exactly I will not be able to create using OpenCog Classic's scheme language, and what super important real-world valuable thing Classic didn't allow to create. Give an honest technical reason. So some indirect parts of the answer were already given, but I would like still to make a few comments. So OpenCog didn't have a schema language. It had and has an integration with schema language. The internal language of OpenCog Classic was Artemis, as I mentioned, and one of the issues was, for example, for Neil Geisweiler to implement the unified rule engine. He had to code in C++ and in Scheme, and the whole rule language was coded in C++ with the use pattern matching queries on top. But Artemis was not enough to create the unified rule engine. And the unified rule engine was a sort of language by itself, but it was specialized to logic-like processing. And when we wanted to create quite straightforward symbolic rewriting rules, for example, for automatic differentiation, then there were some problems because the inference was not controllable, and we didn't get the only result we need, and so on. And one of the reasons was for inventing Meta was exactly to combine functional style processing with logic style processing. But it's not the end of the story. Actually, I started collaborating with Ben initially on the idea of OpenCog probabilistic programming. And probabilistic programming is a sort of most general way to specify generative models. It can encompass also neural generative models, but it is much wider, and different concepts from AGI, like universal induction, also fall into probabilistic programming. But in probabilistic programming, the inference engines typically use such methods as Metropolis Gastings algorithm, or Monte Carlo different types of Monte Carlo Markov chain algorithms. They simply randomly sample from a distribution, and at best make some mutations, but if the task has some logical structure, then it is possible to infer very strict limitations of on what to be sampled, while all these engines will suffer from exponential explosion using a combination of logic inference, which will work from the conditions which we want to impose back to the random choices made in probabilistic programming. It could be made much more efficient, and this was one of the ideas to introduce to OpenCog. But when we tried to do this, once again we had to write some custom code in a host language like C++, and the worst thing was that it wasn't combinable, interoperable with other similar engines written also in host language. So some components were written in C++, others in Scheme, others in Python, and they were written in such a way that there wasn't a cognitive synergy which we wanted to achieve. So the technical answer is that we need to go a little bit deeper and try to unify everything to create a basis for the same cognitive substrate for evolutionary programming, for probabilistic programming, for logical inference, for functional programming. And if we are able to create some such cognitive firmware, then we will be able to get this cognitive synergy from all these modes of operation. So the idea of cognitive synergy, although OpenCog Classic had an atom space as a central place where different cognitive algorithms can cooperate, it was still not enough to achieve this cognitive synergy in a very productive way, like on the level of inference control, on the level of sampling algorithms or tree search algorithms or reasoning algorithms or whatever. So they were like working in separate spaces. They were like a bunch of experts which communicated to each other only rarely, instead of really deeply interoperating and synergizing. So everything can be written in Scheme or assembly, as was mentioned, but basically you when you try to do this, you will need to invent some form of language to for all these cognitive algorithms to interoperate. I'm not sure if it's technical, if this explanation is enough technically, but it's difficult to go in more detail just in words. But I wanted to mention this because it was really an important turning point for us from OpenCog Classic to Hyperon and Meta. Thanks.
Yeah, and I really recall that as well. You know, from all my discussions with yourself, with Ben, with Matt, we ran into some fundamental limitations. You know, OpenCog Classic was a great prototype, a great proof of concept, and still for running on an individual machine and doing some experimentation. You know, it showed us that we appeared to be on to something with our cognitive architecture, with the OpenCog stack, with what we're now calling Primus. These pieces working together on a shared atom space was extremely promising. And then from that spot, like any production practice, you need to move beyond the prototype. You need to build the widget that's actually can be produced at scale and actually fits the pieces that you want. Not that just shows that it will, but can actually be used on a broader scale. And I recall us running into these obstacles, that we can see what we can do, but when we try to go large, really do some deep dives into longevity to the bioatom space, we were just stuck. We couldn't get to the spot we wanted to with more ambitious attempts to utilize the OpenCog Classic within our team as a fairly large team with fairly robust technical desires to build solutions. And so the meta language was carefully thought through. Meta language and distributed atom space were carefully thought through innovations, carefully considered. Is it time? Do we need to do something completely different? Can we just continue to kind of make stuff work? And it wasn't going to work in the long run, right? We needed to build something that went from prototype to production, more production ready models. And we have that now. We've got the alpha. Excitingly, it's taken the amount of time that we hoped, and it's now an opportunity for developers to get involved, to contribute further, and to see for themselves the power that this, as you say, as you describe, Alexey, this native synergy for AI interoperation can work, and how that can work on a distributed atom space that can be scaled to large servers, to decentralized hardware and beyond, used locally, used globally, and is a lot more flexible in how it stores the symbolic concrete language that doesn't hallucinate, that has real grounding in reality, in shared reality, and the world we live in, so that AI can be synergistic and can understand the problems that it's looking to solve, not just generate a response, but actually understand the problems that we're working with it. It becomes synergistic with us through these processes. I hope I touched on what you yourself summarized. So again, thank you very much, Alexey. It's very exciting to have you here. I am looking forward to everything the team is building right now and rolling out right now for the community to see and engage with. We'll have more demos coming out through the months. We'll also be at AGI 2024. Registration's opening very soon for that. That'll be August 13th through 16th. It'll be in Seattle again, so that should be exciting. We'll have a demo of the bioatom space, the bioinformatics, bioatom space, bio OpenCog integrations that we're working on right now, so that people can see OpenCog Hyperon and how it's being utilized in a real world, an important use case, as well as what Ben mentioned, the mind children use case as well. There's going to be a great workshop and demo incorporating the small robots that we're building. Next week, we'll have a Tech Tuesday that dives into some of the experiential learning pieces promised a couple weeks back that we're finally having an opportunity to get back around to, which should be very interesting as well, getting to see these systems and how OpenCog Hyperon helps AI experience the world and do some things that are fundamentally different from AIs that may be more familiar currently. Any closing thoughts from you, Alexey, to share, or shall we sign off? And
I just want to thank everyone for their interest. Hope you will not be disappointed by the current state of Hyperon. Please take note that this is a work in progress. Actually, my initial mistake about OpenCog Classic was exactly when I first encountered it in like 2007. I thought that it's nothing special, but it's just because it was a work in progress, and then I understood my mistake, and now and then I started working on OpenCog because the roadmap towards AGI cannot be done instantly, and we should really distinguish what is the current stage and what are the plans.
Yeah, thank you very much for that comment. Still a work in progress, looking for some devs who are into complexity and want to start to dive into and learn and co-develop meta, distributed atom space, and the other components of OpenCog Hyperon with the team. And we look forward to broadening that out to everybody who's a fit for that and interested. So meta-lang.dev, we can put that again in the comments. If you want to learn more about Hyperon itself, you can go to hyperon.opencog.org. You can see some of the AGI talks that we've given on the topic that dive into that process. And we look forward to seeing everybody back next week, seeing folks at AGI 24. And thank you very much for joining us here today for this launch, this exciting launch of Hyperon Alpha. Thank you very much.